Hi, and today we're going to look through A-Level Stats, Year 1, Chapter 2, Measures of Location and Spread. So this chapter is all to do with averages, interquartile ranges, and standard deviation. So let's get started. First thing I'm going to start off with is to recap how to find the mean with group data. This is really easy, but people always seem to forget it, so I thought I'd quickly go over it. So you've got two types of data, which we saw in Chapter 1. We have continuous, where the height can be any number, and on the opposite of that we have shoe size, which is discrete, which means they can only take particular values. So you can't have shoe size 7.2, for example. Okay, finding the mean for both of these is pretty straightforward. For continuous data, you start off with taking the midpoints and do that for all those points, and you then do midpoint times frequencies. For the discrete data, you just do number times frequency. Work that out, which is done here. That then gives you this row of numbers for height times frequency and shoe size times frequency. You then want to add up this column and this column. Doing that will give you the total height of everyone and the total number of people, or in this case the total shoe size of everyone and the total number of people. From there you can just fairly easily work out the mean by doing the total divided by how many people there are. So that's your average height in centimetres, and we do the same here, and that's your average that's your mean shoe size. Quick aside, you're often asked to explain why this is only an estimate. This is only an estimated value because of the fact that right at the beginning we took these midpoints, and because the midpoints weren't the exact values, this isn't a perfectly accurate value, it's just an estimate, and often you're asked to explain why that is the case. Okay, next we have finding the median. Okay, now this is slightly different if you have group data, if you have discrete data or continuous data. Okay, for discrete data, again like shoe size, you basically do what you've been told since the days of GCSE. You would get the total number of pieces of data. So here n is the total number of pieces of data. You would add 1 to it and you would divide by 2. And we do roughly the same thing for the lower quartile and upper quartile. So lower quartile, you do n plus 1 over 4. Upper quartile, you do n plus 1 over 4, and then times it all by 3, because it's 3 lots of the lower quartile basically. Continuous data is a bit more straightforward. All you do is just ignore the plus 1. Okay, as far as I'm aware, there's no real reason for this. It's just some of the quirks you deal with when dealing with discrete and continuous data. Okay, and if you don't remember it, it means all your answers are going to be slightly wrong when you work things out. Okay, the main thing, or the main new thing from this chapter, or the first new thing, sorry, is using interpolation. Okay, now in the book they explain a formula how to work this out. I personally find that formula really confusing, so I'm going to go through a slightly more intuitive method. So for this question, or this example, I want to find the quartiles. I want to find the lower quartile, which is Q1, the median, which is Q2, and the upper quartile, which is Q3. So here I have continuous data, so I can use my continuous data formula, and that'll tell me what value I want to find. So I want the 17th piece of data, and over 4 I will want the 8.5th piece of data, and here I would want the 25th piece of data. Okay, and we're then going to work out in which class width are each of those pieces of data going to lie. To do that, the best thing you want is to have a running total for your frequency. So I can just move these. So if I have a cumulative frequency, that's going to be 4, 10, 18, 25, 31, and takes up to 34. So I know that the 8.5th piece of data will be somewhere in here, the 17th piece of data will be somewhere in here, and the 25th piece of data will be somewhere in here. However, we can do better than just saying they're somewhere within that class. For example, this median, the 17th piece of data, is going to be a lot closer to the end of this class width than the start. And the other side of things, the 25th piece of data will be right at the start of this class width and nowhere near the end, because 25 was the end of the previous class. And we're going to use that to do our interpolation. Okay, so I'll start with the lower quartile. So for Q1, I want to find how many pieces of data I am within that class width. So what I mean is, I know so far we've got 4 pieces of data. So if I do 8.5 minus 4, that means I want to be 4.5 pieces of data into this class width of 6. So I'm going to do 4.5 over 6, and I know that is the fraction of how far of that class width. That's going to be the fraction of how far into that class we are. Okay, I'm then going to times that by the class width. So here the class width is 10, because it goes from 150 to 160. If I type it on my calculator, that's going to come out at, I think, 7.5. Yeah. Okay. And that's going to tell me how far into that class width I want to be. So this class width started at 150. So therefore my lower quartile will equal 150 plus this answer 7.5 here, because that's how far into the class width I am. Okay. Again, in the book, a formula will do the similar job for you, but I find the idea of working out what fraction into the class width I am a lot more intuitive and easy to remember when it comes to the stress of an exam, rather than a long, slightly clumsy formula. Okay, let's quickly do the same thing for Q2 and Q3. So for the median, again, I want to work out what fraction into the class width I am. So if I do 17 take away 10, that's going to tell me I am 7 pieces of data into this class width. So I'm going to do 7 over 8 times by the class width again, which is 10. That gives me 8.25. So I'm going to be 8.25 units into that class width. So it is the same thing as before. It's going to be the start value. This one starts at 160 plus 8.25. So that'll be 168.25. Okay, and here you don't need to round unless you're explicitly told to round, otherwise just leave it in sort of full abbreviated form. Last one, the upper quartile. Again, doing the exact same thing. Let me change colour again. I know I'm just half a unit out of 6 into here, and a half out of 6 times 10 is going to be, I think, it's going to be 0.083 recurrent. So occasionally you get recurrent, and that's absolutely fine. And then with this, we do the same things as before. We need to times this by the class width, which I haven't done yet. That should be 0.83 recurrent. I only times it by 10. And then we do upper quartile is going to be the start of this class, which is 180, plus 0.83 recurrent. So it'll be 180.83 recurrent. And that's how you work out your 3 quartiles using interpolation. Okay, and then from there, occasionally you have to also work out the interquartile range when you adjust to the upper quartile minus the lower quartile. Okay, and don't forget this Q2 is also is just a median, in case you asked that one as well. Okay, moving on. Same idea. You also asked the same thing to find percentiles. Okay, this is the exact same idea. The 90th percentile is going to be 90% along my data. The way I work it out, I do roughly the same thing. A 90th percentile as a decimal, 90% is 0.9. I times that by the total of pieces of data, which is 34. On my calculator, that tells me I want the 30.6 piece of data. Okay, I can then work out where it's going to be. So again, we can add in our cumulative frequency along the bottom here, and we can see that the 30.6 piece of data is going to be somewhere in this class width. We do 30.6 minus 25. So I want to have 5.6 out of 6. I want to be that far into this class width. So I times it by the class width, which is 10. This I will need a calculator for. So 5.6 divided by 6 times by 10 gives me 9.3 recurring. So therefore the 90th percentile will just equal the start of the class, which is 180, plus this 9.310 we just found out. And that's how you work it out. So the exact same idea, just have a slightly different start. I mean, all the steps the same as before. Okay, that was the first thing, interpolation. Again, you asked it fairly commonly, so make sure you're okay with the method. Now moving on to main measures of spread. So you have three measures of spread that you should be aware of. That's the range, the interquartile range, and the new one for A level, which is standard deviation. Range is the easiest, just the distance between the highest and lowest value. Only uses 2 points, so it's really quick to work out. On the downside, because you only use 2 points, it's not overly informative. It's not telling you too much about the data as a whole, just the 2 extreme points. Next one up from there is the interquartile range. This measures the distance between the upper quartile and lower quartile, so in essence the middle half of the data. Advantage is that it uses more points, and it's also unaffected by outliers. It uses a random value of like 1,000,000, that will really mess up your range, but it won't affect your interquartile range. Last one, or the new one, is a standard deviation. This kind of measures the average distance from the mean. It's not exactly that, but that's the best way to think about it. Advantage is it uses all points involved to calculate it, so it tends to be the most accurate because basically every point will affect the standard deviation. So we're going to look on now onto how to work out the standard deviation. Before we jump into that, just some new notation. If you see this symbol, this means the sum. So this means add up all the values after it. So for example, if you saw this would mean add up all the x values, so it might also have xi, and then divide it by n. So actually this tells you how to work out the mean. Because if your x values were say 1, 2, 3, 4, 5, it would then mean add all those together, so 1 plus 2 plus 3 plus 4 plus 5, and then divide by how many there are, divide by 5, and that would work out the mean. Okay? On to standard deviation. Okay? There's a few formulas you can work it out. What I was kind of taught is that it's the square root of something called the variance, which is roughly the same thing as it. And you can work out the variance using this formula here, which is basically the mean of the squares minus the square of the means. I wouldn't recommend that too much. I mean, that makes more sense to me personally. But for you, you have these formulas in your formula booklet. So I think it makes more sense to be more comfortable using those, even if they're sort of a bit more confusing how they work and how they stick together. Okay? So I'll start off going through a fairly easy example. So I've just got 7 pieces of data here, and I'm going to find its standard deviation. First things first, I'm going to work out what's called SXX, and to do that, I'm going to use this part of the formula, and then with standard deviation, I'm going to use this bit here. In order to do that, I need the sum of the x, so it's the sum of all the values, and also the sum of the squares. So sum of all the values will be minus 1 plus 0 plus 0 plus 2 plus 4 plus 6 plus 7. Okay, that's going to be 13, 17, 19, 18. Sum of x squared will be the sum of all the sum of the squares of my values. So minus 1 squared is 1, 0 squared is 0, 0 squared is 0, 2 squared is 4, 4 squared is 16, 16 squared is 36, and 7 squared is 49. And that gives me the sum of xi squared. How can I use this formula? So SXX is going to be 106 minus 18 squared over the number of pieces of data I have here. And here you've got 7 pieces of data, which means n is going to be 7. So let's work that out. So that's going to be 106 minus 18 squared divided by 7, which gives me 59.7173, which I think is right. So let me just check that quickly. Yeah, that's fine. Sorry, these calculators sometimes don't do bid math properly and kind of break things from there. Anyway, that's my SXX. I can now work out the standard deviation by using this formula. My standard deviation, denoted by this symbol here, which is a lowercase sigma, will be the square root of 59.7143 divided by 7. And you just type it into your calculator, work it out, and then you are done. Okay. Keep in mind, if you have some of the POS calculators, they can work out this stuff for you. However, it is worth knowing the method, because occasional exams, they'll ask you to work it out in terms of algebra, in which case your calculators can't really handle that. Okay, I'm going to quickly go for an example question. I've got one more thing to show you, and then that'll be it for this video. So this is a past exam question. I'm going to sort of go through it step by step. So we have some table of the weight of 1,500 babies. First step, we want to write down the missing midpoints. So the midpoints is a number in between 2.5 and 3.0. That is just 2.75, and in between 5 and 6 is just 5.5. We've also got this data here. They've told us what the sums are. So sum of f of x means a sum of this times this. If they times together these two numbers, that's the sum over here. And the sum of fx squared is the same thing, but with these numbers squared. So in terms of a formula, this term here corresponds to this term here. And the sum of fx is the same as the sum of x, in as far as the formula works with standard deviation. Okay, part B. We want an estimate for the mean birth weight. All we need to do to work out an estimate for the mean is do everything added together, which is 4841, divided by how many babies there were, which is 1,500. Okay, type into your calculator and that'll work it out for you. And you should get that answer. Part C, we want the standard deviation. For that, we're going to work out SXX. That is going to be this thing, which we are given as 15889.5 minus 4841 squared over 1,500. Okay, so let me just work that out quickly. Okay, that's my SXX. It's going to be 265.9793. I can now look at the standard deviation by using this part of the formula. So it's going to be the square root. I'll say 266 over 1,500. So putting me a fairly small number. Okay. I'll just check, can I work that out at all? I can. So square root of 266 over 1,500. Okay, and that fella there is my standard deviation. And again, that's really small, but that kind of makes sense. So we look, these weights are all fairly clustered together. There's like a massive cluster of weights around about 3 kilograms, where not too much goes up to 2 or down to 4. So you'd expect a fairly small value here. So that does make sense. Part D is you're then going to use interpolation to work out the median birth weight. Okay, this we know to do. I'm not going to go through it again because I've spoken enough. Again, you would add up all these values, get a running total, and you try and find the 750th baby and how much that weighed using the fractional thing we saw earlier. Okay, last thing in this chapter is what's called coding data. Okay, it's basically we've changed the values of our data set. So I could code this data using this formula here. So my new data, we'll call it y, is going to be the exact same values, but everything I've subtracted off 100. which gives me this data here. Okay, what you're typically asked is to explain how this will change or affect the mean and standard deviation. So doing the mean first, I'm sure you can see fairly easily, if all my values go down by 100, then my mean will also go down by 100. Standard deviation will not change. The reason for that is the standard deviation is a measure of a spread. It's how spread apart my numbers are. If all my numbers go down by the exact same amount, they're still equally as far apart as they were as beforehand. They haven't got any closer or further apart from each other. So the standard deviation will not change. And that's really important. If you shift all the values up or all the values down, that has no effect on the standard deviation. We can also code data by dividing it by a number. So here I've got all these numbers and I've divided them all by 10, which is going to give me this new set. Now looking straight away, this will affect my standard deviation. Because I've divided the numbers all by 10, that means they're now closer together. So before these numbers were 100 apart, now my coded data, they're only 10 apart. So that will affect my standard deviation. Let's go through them both. Obviously, if you divide all the numbers by 10, you will have to divide the mean by 10. And as you've kind of seen, that because everything's now 10 times closer, that means you will also divide the standard deviation by 10. And again, a really common question is to say, give you standard deviation and mean for a certain set of values, then they do some coding, and then they want the new mean and standard deviation. So you need to know all these tricks. So that was, we've seen taken away, we've seen dividing. Last one they can throw at you is when they divide and take away. So here I'm subtracting 100 and then dividing by 10. So here I'm going to have the new set of coded data, which will look like this. Okay, basically just combining those previous rules. The standard deviation doesn't care that we've subtracted by 100, but it does care we've divided by 10. So my standard deviation will be divided by 10. The mean, remember, has been affected by both those things. So for the mean, you'd subtract 100 and then divide by 10. So you basically do the same patterns of what you've done to these numbers as well. Okay, hope that made sense. That's all the key points from this chapter. There are some exam style questions in the description. Feel free to give them a go. And it covers most of the main areas and the kind of topics they kind of like throwing at you in exams. Okay, thanks for listening, and I hope that's helpful for you.